Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Yeah, my favorite artifact, Pascal Triangle. Blaise Pascal is one of my favorite mathematicians. I see a lot of secrets embedded in these numbers. And if you don't know what Pascal Triangle is, you can watch, other videos in the math playlist that would explain it to you. And basically, is we start with one, and then the next line after that, all the lines starts with one and end with one, and then they increase by one number. So here's a single number, two numbers, three, four, five, six, and so on and so forth. And the middle numbers, we always make them the sum of the two above it. So the 2 is 1 plus 1, the 3 is 1 plus 2, the 35 is 15 plus 20, and so on and so forth. Now, again, if you raise the 11 to the power of 0 or any number to the power of 0, you get 1. 11 to the first power, you get 11. 11 squared is 121. 11 cubed is 1,331. But of course, as you go to the fifth level, you see that you have to carry over 1, so it breaks up. But that's not what interests us. If you did the binomial expansion, so if I tell you what is x plus y to the fourth, you see that you go to the line that starts with 4 after the leading 1, and you see that these would be the coefficients of x to the fourth and x cubed y, x squared y squared, and so on and so forth. So you can easily find that. In fact, even in probability, you have applications for the binomial distribution, of course. You can find a lot of things. But what I want to go over that today, which I think I did a video a while ago about it, but maybe it wasn't clear. And this one is for okay, this one is for trig. So in trig, the Pascal triangle, using Pascal triangle to do what? To expand or to write sine of nx and cosine of nx in terms of sine to any power of x and cosine to any power of x. What does that mean? Well, let me reproduce the Pascal triangle because I don't want to write on this because I use it a lot, right? Okay, so I'm going to write it down. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. You see that it's symmetric. I'm going to stop here. So the first thing you have to understand is that the first element in any row is the highest degree of cosine, cosine to the n. We'll see what does that mean in a second. The next will have sine to the first power and cosine to n minus 1. And you keep so the degree of the cosine decreases and the degree of the sine increases until we reach here, there is only sine to the n. The coefficient as you go are positive, negative, always alternate, starting always with positive. When I expand the cosine, I start with the first element, skip 1, move to the third, skip 1, move to the fifth, skip 1, and so on and so forth. But when I start with sine, I skip the first and take the second, skip the third, go to the fourth, skip the fifth, and take the sixth, and so on and so forth. So the odd numbers, first, third, fifth, belong to the cosine. Second, fourth, sixth, the evenly placed numbers, belong to the sine. Okay, having said that, now it's a little confusing, right? How can I remember all of this? Of course you know, but I'm going to ask you, how do you expand sine 2x? Sine 2x. You should know by now that sine 2x equals 2 sine x cos x, right? Where does this 2 come from? Remember what I said. I said if it's nx, I go to the row of 2. The first one belongs to the cosine. It's cosine square. I don't need it because the sign starts with second. So when I go here, I see 2. Notice this was cosine square. The cosine decreases by 1, and there was no signs. The sign increases by 1, the degree. But when I tell you what is cos of 2x, I would start with this one, and that's the highest degree. Notice the degree matches this. So if I'm in the second row, this would be cos square x. I'm going to skip this one that is sine cosine, and then go to this one that doesn't have any cosine. It has sine squared. But remember, we said the second term is negative. I alternate the signs, and that becomes sine square x. These you should know by now. You should know them from trig, right? Trig identities and stuff, and double angles. Now let's take 2 higher values. So for example, suppose I want you to do sine of 6x. Listen to me. I'm going to go to the row of 6. We call it the 6's row. And how do I know the row number? Of course, everyone starts with 1. Go to the second digit. The second digit is what I'm looking for. Again, this one is cosine to the 6. This one is sine to the first, cosine to the 5th, right? Because the power decreases by 1. So I'm going to write 6 sine x cosine to the 5th x. I'm going to skip this one, go to that one, and write minus 20. Notice the sine increased by 2 because here it was sine, here it became sine square, here it becomes sine cube. So sine cube of x. This one was cosine to the 6th, to the 5th, to the 4th, to the 3rd. So cosine cubed x. Then I'm going to skip this one and go to the last one, which is positive 6. Now, notice that the cosine to the 6th became to the 5th, 4th, 3rd, 2nd, 1st. Notice you always decrease by 2. Cosine cube becomes cosine, cosine to the 5th become cosine cube. Well, here it will become cosine, just cosine. The sine was to the power of 1, to the power of 3, so to the power of 5. I did it. Then you can take these, and someone would say, okay, can I break sine cube into sine square times sine x for some reason? And then the sine square, I can make it 1 minus cosine square. You can do whatever you want. But this is a very quick way of expanding sine nx or cosine. Let's take one for the cosine so that we are we fully cover that, and that would be the end of it. There is nothing really more to say about that. Let's say cosine 5x. I start with the first element, then the third, then the fifth, right? For the sine, I started with the second, then the fourth, then the sixth. Even, odd. Odd with cosine, even with sine. The first one is cosine to the 5th of x. They match 5 and 5. Then I skip 2. So it would be minus. Notice it's always positive, negative, whether I'm doing sine or cosine. Oh, I'm sorry. I'm in this row now. I was going to take this by error. So I did the cosine to the 5th. This is cosine to the 4th sine, and this is cosine cubed sine squared. So usually we write this sine first. It doesn't matter. So I'm going to write sine square x cosine cube x. How do I know? Well, the sum of the degrees always have to match the 6. Here they have to match 5. So this is 5 for cosine, 0 for sine. Here they become 2 and 3, and then they would be 4 and 1, right? I'm going to skip this 10 and go to the 5. The negative becomes positive 5. Here I have sine to the 4th of x cos x, and I'm done. Now, if you want, you can go online and go to any computer program and say expand sine 6x or expand cosine 5x, and you will get that very easily. And there's one other hidden jewel in Pascal Triangle that I love a lot. I hope it was easy for you to cover. I mean, if you go over these couple of examples, you will see how easy they are. And again, wish you all the best and hope it was helpful to you. Thank you very much and see you soon.